In this demo, we'll implement different kinds of classification models in scikit-learn. Each of these classification models use a different algorithm under the hood. We'll implement different classification models in this same Jupyter notebook. This demo will span this entire module and will be interspersed with conceptual descriptions of the different kinds of algorithms that we use here. We'll write all of our code in this notebook called Multiple Classification Models Titanic. As usual, we'll set up the import statements for all of the libraries that we'll use along the way: pandas, numpy, train, test, split, and all of the metrics to evaluate our classifier. And here are the imports for the different scikit-learn libraries that we'll use to implement different ML models. We'll start off with the Logistic Regression classifier and move on to other models along the way. We'll work with the same Titanic dataset to build and train all of these models. We've already explored, cleaned up, and processed this dataset. This is in the titanic_process.csv file. Here are the features that we'll use to train the different models. You can see that categorical values have been either label encoded or one-hot encoded. The target label, what we're trying to predict using our model, are values in the survived column. So let's extract the features from this data frame. All columns starting from column 1 onwards are our features. Here are all of the features we'll use to train the different classification models. For each of the models that we build and train in this notebook, we'll evaluate the accuracy, precision, and recall of the models on test data and store the results in a dictionary format. This is the result dict. The keys of this result dictionary will be the different models that we build, and the values will contain the evaluation metrics for each of the models. I'm going to first set up a few helper functions that we'll reuse in this notebook. This is the summarize classification helper function, which takes in the actual as well as predicted Y values from our model and quickly summarizes the different scores. Within this helper function, we calculate the accuracy of our model in terms of a fraction, and we also get the number of accurately predicted labels from our model. When you pass in normalize is equal to true to the accuracy score function, you get accuracy in terms of a fraction, and when normalize is equal to false, you get the number of accurately predicted labels. This helper function also calculates the precision and recall of a model, and we return all of these scores in a dictionary format. We'll use another helper function called build model to help us build and train the different classification models here in this notebook. Build model takes in a number of input arguments, and we'll study each of these in detail. The classifier function is a function that we'll define. This function takes in the training data and the training labels, instantiates an estimator object, and trains the model. The name of Y call is a string which gives us the column in our data frame that contains our target labels to use for training. The names of X calls gives us the column names of the features that we use for training. This is specified in the form of a list. The dataset input parameter contains the data frame that holds our training data, and the test fracs tells us what fraction of the data we should hold out for testing our model. Extract the X variables, that is the features we'll use for training, and the Y values from our dataset. We are familiar with this process. We then use the train test split function from scikit-learn in order to split our dataset into training data and test data. Because this is a helper function used to build and train different classifier models, we call the classifier function to instantiate the right estimator object and train the model. The classifier function will then return an instance of the fully trained model, which we'll then use to predict on the test data. We'll also use the model to predict on training instances as well. This will allow us to compare how the model performs on new data it hasn't seen before and how it performs on training instances which it has encountered before in the training phase of the model. We summarize our classification model by calling the summarize classification helper function that we just defined earlier. Within the build model function, we'll also instantiate a data frame containing actual versus predicted values on the test data and calculate the confusion matrix. And finally, we'll return all of these bits of information in the form of a dictionary. We have the training summary, the test summary, and the confusion matrix on the test data. I'm going to write one last helper function here, which will allow us to quickly compare the results of the different classification models that we build. In this helper function, we'll use a for loop to iterate through the result dictionary, which contains the results of the different classification models. For each of these models, we'll print out information on how the model performed on training data. This will be with the header training data. We'll access the training scores for a particular model using the training summary that was returned from the build model function that we saw earlier. In exactly the same way, we'll access the test summary scores as well. Now that we have all of these reusable helper functions set up, we'll now see how we can use these helper functions to build and train a logistic regression model. We first define a function that takes in training data and training labels. This instantiates a logistic regression estimator and calls fit on the estimator to start training, and we return the fully trained model. With the helper functions that we've defined, you'll find that it's very easy to build and train a model. We simply called the build model function and pass in the logistic function. The logistic function is what will instantiate the logistic regression estimator and train it. The survived column is our target label, and we use all of the features in our Titanic dataset. The training and test results of our logistic regression model will be stored with this key in our result dictionary, survived logistic. And finally, we call compare results to quickly print out the training and test scores for all the models we've built so far. Let's execute this bit of code and see how it works. We've just built and trained one classification model, and the results are right here. For our logistic regression model, the training accuracy was about 80%, the test accuracy was about 77%.